Okay. So,
अस्सलाम वालेकुम सर।
Walaikum.
जी ये रोल नंबर 18 जुबैर फोन कर रहा था मुझे कि इसका लीव हो रहा है बार बार। इसने आपको टेक्स्ट भी किया शायद व्हाट्सएप
We'll see. कोई बात नहीं.
बार बार लीव हो
Okay.
रहा है।
Line to line fault. We have one numerical number. One is 100 MVA, 11 kV. Z1, Zn is Z0 is 0.1 per unit. Zn is equal to Zf 0.05. Line to line fault occurs between phase B and C. Find IF in per unit, IF in actual, short circuit MVA, and short circuit MVA in per unit. So let's solve this numerical. Okay. Now, solution for this one is we have fault current in per unit we have seen last time is equal to under root 3 EA1 divided by Z1 plus Z2 plus ZF. So this we can write under root 3. EA1 obviously will be 1 per unit. Z1, Z2 zero sequence is not there. So that will be 0.1 plus 0.1 plus ZF is 0.05. So that value comes out to be IF in per unit is 4 under root 3 per unit. This is the value of IF in per unit. Now next is IF in actual. This is first part of the question. Second is IF in actual will be equal to 4 under root 3, that means IF in per unit, multiplied by MVA, that is 100 into 10 to the power of 6, divided by under root 3 into kVA, 11 into 10 to the power of 3. This comes out to be 36.36 kilo amps. Okay. Next is short circuit MVA. Short circuit MVA can be written as under root 3 E into IF in amps or kiloamps, whatever you want to. So that is under root 3 into 11 by under root 3 because we are in line into IF is 36. So let us have here kiloamps. 36.36. This is in kiloamps. So short circuit MVA will be 400 MVA. Fourth, short circuit MVA, that was in short circuit MVA in per unit now. Short circuit MVA in per unit is EA1 in per unit multiplied by IA in the same sequence in per unit. So IA1 in per unit we have seen in case of line-to-line fault is EA1 divided by Z1 plus Z2 plus ZF. And that value comes out to be EA1 will be 1 per unit because base value divided by EA1. Somebody may already have explained this. Actual divided by base value is 1 per unit. So short circuit MVA will be equal to 4 per unit. Substitute the value of E as 1, Z1 and Z2. These values you know. I'm not writing these values. You can substitute it and this will be equal to 4. And from here, if you know, you can find the actual value also. In actual, that is 4 into what is the base value? Base value is 100. that is 400 MVA. Any method you can find. Another one more method you can find, but if you want to find it, he has not given. Maybe she will ask you to find IA1 in actual. You can find that IA by under root 3 also. And short circuit MVA can also be obtained like this: 3 EA in volts into IA in amps. So that is 3 into, that is 11,000 EA under root 3 volts. We are talking not in per unit now. IA1 we know this 3.36 divided by under root 3, that is also in kiloamps. So you can simply write this will be equal to 400 MVA. So there are lots of methods you can find these values by using the appropriate formulas. Okay, very simple. These are the gate type of numerical. This is not a gate numerical, but the numerical, they will either ask you per unit or actual values. If you know the right formulas, you can always do it. So next is another problem we have. Find the subtransient current and the line to line voltage at fault under subtransient conditions when line to line fault occurs at the terminals of the generator. Okay. This is the same numerical which we have last time. Assuming the generator is unloaded and operating at terminals voltage when the fault occurs. Using the previous values we will be described in previous problem. So here same data we have last time, so we will be using the same data. In this case we will first find IA1. IA1 is 1 plus J0, that means EA divided by Z1 plus Z0. ZF is 0 in this case. Z was what? That was J.25. Previous data we have to use, plus J.35. So that is coming out to be minus J1.667. Okay. That's in per unit. And then also we had seen in case of line to line fault, IA1 is equivalent to IA minus IA2, that we have seen in the sequence diagram. So you can write it 1.667 per unit. And zero sequence does not exist in case of line to line faults. That is IA0 is 0. IA is equal to IA0 plus IA1 plus IA2. So this should be 0 because fault occurs in B and C. So A is an unloaded alternator, and this value has to be 0. So IA0 is 0, IA1 is IA2 is plus J1.667, that is minus 1.667. So this is 0 amps in this case. But if you have to find IB is equal to IBO0 plus IB1 plus IB2. But in terms of A, how we can write it? We can write it IA0 plus A square IA1 plus A IA2. If you substitute the respective values, so IB will be I0 is 0 plus, so A square you can write down is in terms of minus 0.5 minus J 0.866 multiplied by IA1. IA1 is minus J 1.667 plus minus 0.5 plus J 0.866 into IA2. IA2 is J 1.667. Okay. So this is minus, yeah, minus plus. So this value IB will be equal to yeah, IB is actually equal to IC minus IC Yeah, IC is equal to minus IB. So therefore IC will be 2.866. 886, sorry, per unit. That means if this is this, then IB value will be minus 2.886 per unit. So these relations are very important. You have to remember these relationships. Conditions, post-fault conditions. So base current we need to find. Base current will be MVA. That is 20 was there MVA, 10 to power of 6 under root of, no, it will not be 6. If we are considering KVA, then it will be 3 only. 3 under root 3 into 13.8 was in KVA, so it will be nullified. So that was, we have already got it, 837 amps. So IA was equal to 0, that we know, fault had occurred in B and C. IB in actual will be minus 2.886 per unit value multiplied by the actual value, 837. That was equal to 2416 at an angle of 180 degrees. And IC value will be 2.886 multiplied by 837. That was equal to 2416 at an angle of 0 amps. Okay. So next is symmetrical components of the voltage for from A to ground. Of voltage from phase A to ground. VA1 is equal to VA2 is equal to 1 minus 1. VA1 is equal to what? EA minus IA1 Z1. IA1 is what? J 1.667. I'm not writing the formula. I think you know now formulas. 0.25. That will be 1 minus 0.417, and that value is 0.583 per unit. Okay. VA0 was equal to 0 because I of 0 is 0 in this case. Neutral of generator is grounded, but this we already know. VA naught is IA naught multiplied by Z naught. Since 0 sequence voltage is not there, so this will be 0. So line to ground voltage now. Line to ground voltage is VA was equal to VA naught plus VA1 plus VA2, and that is 0.583 plus 583, that will be 1.166 at an angle of 0. How come we are getting? VA naught is 0, VA1 we have got, both are equal in case of what? In case of line to line fault, VA positive sequence is equal to negative sequence, so we can multiply them 2 and we'll get the value. VB is VB naught plus VB1 plus VB2. That will be VA naught plus A square VA1 plus A VA2. Now you substitute these values. VA naught is 0. VA naught is 0 in this case, plus A square is minus 0.5 minus, it's in rectangular value, 866 multiplied by VA1, which is 0.583, plus A is minus plus J 0.866 multiplied by again 0.583. So if you find this value will come out to be, VB will be, I think, minus 0.8583 per unit. This is the value of VB we will be getting. Next to this is Next is VB is equal to minus, that we already know. So VB value we have got. VB is equivalent to VA VB. Now, okay, what is the VC value? I think VC value we are going to get. VC will be VC naught plus VC1 plus VC2, that is VA naught plus AVA1 plus A square VA2. So if you find this value, this will come out to be minus. B value is also, this is same. VB is equivalent to 0.83. The values are same. VB is equal to VC in this case. So you will get that value will be same. So now line to line voltages. Line to line voltages will be VAB will be VA minus VB. Okay, so VA is 1.166 at an angle of 0 plus 583, that will come out to be 1.749 at an angle of 0 in per unit. Then next we will have VBC, that will be VB minus VC. VB is 0.583 minus VB, sorry, minus. Yeah, minus. Yeah, minus. And this will be plus. So it will become 0. 0.583. This will become 0 in per unit. Similarly, VCA will be VC minus VA. VC is minus 0.583 minus, okay, what is this? VA is 1.166, that will be equal to 1.749 at an angle of 180 per unit. Okay. I'm not including J values. You can see we are bothered more about the magnitude, but you can take J values also. Okay, so it will come out to be 180. Okay. So line to line voltages in actual expressed in volts. That means in actual values. Line to line voltages. What will be? So VA will be 1.749 multiplied by the actual value, but that is the phase value. Okay. 1.13.94 at an angle of 0. That is in, I think, kilovolts. Yeah. So VBC is 0. VCA is minus 1 point, sorry, not minus. Sorry. That is 1.749 at an angle of 180. Okay, you can multiply it by 13.8 divided by under root 3. This value is 13.94 at an angle of 180 degree in kilovolts. So same approach what we have done in the last problem. There is no difference at all. Exactly the same approach, but just the expression and the values. What are the expressions we are getting in the line to line? We have to use them. Those values we have to use them. Rest all approaches are same. Line, first line to ground, then line to line, then actual values of line to line. You can find the base values. So next we have, next what we will be having is double line to ground fault. Just for a second. So before that we had some problems with gate numericals also. Just a second. Yeah, we had some gate numericals also. So I think that we will be taking next time. Gate type of problems. There are lots of problems in front of me. Gate 2006, Gate 2014. So those problems we will be taking later on. Okay. Now first today, what we will be doing first, we'll be doing the double line to ground fault on an unloaded alternator with a fault impedance ZF as already seen. Okay. So this figure is for what? Figure is for double line and to ground fault. So now two lines are there already short circuited, but there is a fault impedance, and that's with the ground. Earlier we don't have any grounded path through an impedance. Earlier we had only line to line fault between two lines. Fault with fault impedance ZF and neutral impedance Zn. Okay. Here we can say that fault impedance is ZF. So post pre-fault conditions I am not going to write now. Everybody knows that. Pre-fault conditions. It's an unloaded alternator. So this all will be, this is pre-fault unloaded alternator. Post-fault conditions are very important for me. Okay. Moomin is there? Moomin? Okay. Sana is there?
Yes, sir.
Send me the log right now. ठीक है जो भी log है वो जल्दी भेजो 27 students का. Okay. What will be the post-fault conditions? Rutba is there, 27 roll number? No, she is not there. Roll number 6. Arshid Manzoor. Roll number 6. Roll number 6. Delete him. Okay, roll number 39, Furqan.
Yes, sir.
What will be the post-fault conditions in this case? Shabash. Fault has occurred between phase phi and Z, B and C with a fault impedance ZF. What will be the post-fault conditions? Okay, roll number 33, Rafid.
Yes, sir.
What will be the post-fault conditions?
Post-fault.
Just a second. Roll number 2, branch change. Arsalan is there?
Yes, sir.
What will be the post-fault condition? Jaldi.
सर पोस्ट फॉल्ट कंडीशन सर जिन मतलब जो सर दो मतलब एल के दरमियान सर जो ये होगा सर वोल्टेज वो सर शॉर्ट हो जाएगी वो वोल्टेज सर हमें 0 मिलेगी.
आप 8th सेमेस्टर में पहुंचोगे आपके आंसर यही होंगे. रोल नंबर 28.
यस सर.
व्हाट्स द पोस्ट फॉल्ट कंडीशन इन दिस केस?
सर आई होगा सर 0 के बराबर.
आई होगा 0. दैट्स का गुड.
सर आई
What else?
IB is equal to IF is equal to minus IC.
What?
Sir, IB is equal to IF is equal to minus.
No, that is wrong. IF की के तो यहाँ कोई है ही नहीं है. IF कहाँ से आएगा इनके बराबर? That is impossible. Fault condition will be IF will be IB plus IC. अब देखो अच्छी तरह, फॉल्ट कंडीशन यहाँ फॉल्ट आ रहा है तो दैट किरचॉफ्स करंट लॉ यहाँ पे लगाओ इस पॉइंट पे।
सर VB और VC 0 आएगा।
कैसे 0 आएगा? आपकी अकल है क्या है? कौन सी इलेक्ट्रिकल इंजीनियरिंग पढ़ी है आपने? दिस IB इज कमिंग हियर, IC इज कमिंग हियर, IF इज आउट गोइंग, सो IF विल बी इक्वल टू व्हाट? IB plus IC. That is correct. What else? शाबाश।
IAB
हाँ
सर IA 0 आएगा और सर VB और VC 0 बस सर।
वो हो गया। VC 0
बस
कैसे आएगा? ये क्या उसके बीच में फॉल्ट इम्पीडेंस है, उसमें ग्राउंड के साथ डायरेक्टली थोड़ी है वो। रोल नंबर 30 इज देयर।
यस सर।
ओके, व्हाट विल बी द सेकंड? जल्दी जल्दी, इतना टाइम नहीं है मेरे पास।
यस सर।
ओके चलो अब मैं पहले देखता हूँ। रोल नंबर 33 इज देयर। 33 रोल नंबर।
सर 33 या 43?
नो 33। ओके 39,
यस सर।
45,
यस सर।
49,
Yes, sir.
53,
Yes,
53,
sir. Yes, sir.
63,
यस सर।
64,
Yes, sir.
67,
यस सर।
12,
Yes, sir.
16,
यस सर।
29,
Yes, sir.
24,
Yes, sir.
51,
Yes, sir.
55,
Yes, sir.
42,
यस सर।
31,
यस सर।
8,
यस सर।
21,
Yes, sir. Present, sir.
1।
यस सर।
1 कौन है ये?
सर शाहिद नजीर।
27,
Present, sir.
66।
प्रेजेंट सर।
है ना पिछला? बेटा वो लॉग डिलीट करो, यही लॉग भेजो।
Okay, sir.
Okay. Okay, have a look. See there, if you apply a KCL there, then IF will be simply equal to, sorry, fault current. Apply the KCL there. Fault current will be IB plus IC. Why? Because IB is coming like this, IC is coming like, IF is going down. Okay, that will be 1. Voltage here will be same as voltage here. Both points, there is no impedance in between. ये short circuit line है. So those voltages will be same, but what that voltage will be equal to? That will be this voltage with respect to the ground path. What will be that? VB will be equal to VC will be equal to ZF into IF. So VB will be equal to VC, that will be equal to IF into ZF. But IF we know is IB plus IC into ZF. So this is the equation number 1, very important. If one knows how to find the boundary conditions or this post-fault conditions, it is very easy for him or her to derive rest of the expression. Okay, the sequence networks are, we know, equations are, so we know positive sequence has only the voltage source EA1 minus IA1 into Z1, then negative and zero sequence does not have IA2 into Z2, VA0 minus IA0 into Z0. So let us call this second set of equations. So we know also IA plus IB plus IC is equal to IN. Okay, and that is equal to 3 IA naught that we have already seen earlier. So here IA is 0. So IB plus IC will be equal to 3 IA naught. From this we can get this. So let us call this equation 3rd. Okay, so next is equation 1 will become now from this equation 1. What is equation 1? So equation 1 is this one. This one, yeah. So therefore, what is equation 1? VB is equal to VC is equal to IB plus IC, that's equal to fault current, into ZF. This is the equation 1. Now, what is the value of IB plus IC from above equation? 3I naught ZF, we can write it. So VB will be equal to VC will be equal to 3I naught ZF. Now we can write either of these. VB will be equal to VB is equal to VA naught. I am directly writing A square VA1 plus A VA2. So therefore VA naught plus A square VA1 plus A VA2, substitute in this equation, above equation, will be equal to what? Will be equal to VC. VC is what? VA naught plus A VA1 plus A square VA2. Okay. So you can see, you can cancel off 0, 0 will be cancelled. So out of this you will get VA1 is equivalent to, or we can do it A square. So this will be A square minus A VA1. Here it will be VA2. A square minus A square, and this will cancel. Therefore VA1 will be equal to VA2. That means in case of double line to ground fault with fault impedance ZF, positive and negative sequence voltages are same. Let us call it equation number 4. Okay. Next is using the relationship. What is that relationship? Relationship is VB is equal to 3IA naught ZF. We'll be using that relationship. Okay. So VB is what? VB is VA naught plus A square VA1 plus A VA2 in terms of symmetrical components, and that will be equal to 3IA naught ZF. Okay, so VA naught, will keep it like this, plus because VA1 is equal to VA2. So what we can write here? We can write A plus A square is VA1. That is equal to 3IA naught ZF. Why we have written this? Because we have just proved VA1 is equal to VA2. Okay. So we know the relationship 1 plus A square is equal to 0. A plus A square will be equal to -1. So we can definitely write that. So here further this equation becomes VA naught minus VA1 will be equal to 3IA naught ZF. So let us call this equation 5. Okay. Substituting the values of VA1 and VA naught in above equation, that is 5. Substituting the values of VA naught and VA1 in equation 5. So what we are going to get, and what we need to also do, we need to express everything in terms of IA and Y, expressing the equation in terms of IA1, that we have to make everything in IA1. Let's see how we can make it. So VA naught minus VA1, we can write it like this. we can write VA1, we can take it other side, will be equal to VA0 minus 3IA0 ZF. So I have taken VA on this side, I have brought this 3IA0 ZF on the other side. I will substitute the value of what? We'll be substituting the value of VA1. VA1 value we know is EA minus IA1 Z1, that we know, minus will be equal to, what is the value of VA0? VA0 in this case will be minus IA0 into Z0, but here we have neutral grounded, so that will be 3ZA, and that's very important for us. I think, yes. Yeah, here we have done a mistake, sorry. We should have written it properly. It should be, yeah, minus IA0, since neutral is grounded, so that will be Z0. It is impedance or reactance grounded, so that is important. Okay, ZA0, IA0 minus IA0, Z0 plus 3 Zn, and then we have the same value, 3 IA0 ZF. Okay, now what we'll be trying to get, we'll get IA0 here. So IA0 will be in terms of IA1. IA0 will take common, so it will be EA. Okay, minus will also go here, minus EA minus IA1 Z1. Okay, IA0 is common, minus has gone there, everything will come out to be plus now. So that is Z0 plus 3Zn plus 3ZF. Okay, so this is equation number 6 we are getting. Simple manipulations we have done so that everything, now IA0 is in terms of IA1. Similarly, we'll try to get IA2 also. Now, using equation VA1 is equal to VA2. This is also we have derived it. So VA1 is what? EA minus IA1 Z1, VA2 minus IA2 Z2. So let's get that IA2 in terms of IA1. IA2 will be equal, this will become minus here EA minus IA1 Z1, okay, divided by Z2. Let's call it equation number 7. Okay. We know IA is equal to IA0 plus IA1 plus IA2. Okay. And we know IA is 0 in this case, post-fault conditions. No fault occurs at phase A. So this is 0. Okay. Then what we have, IA0 value we have got just now. IA0 is minus EA1 IA1 Z1 divided by this value. So I will write it. Substitute the 6th equation here, minus EA minus IA1 Z1 divided by Z0 plus 3Zn plus 3Zn. So instead of IA, we have used the value. Okay, then we have to use instead of I2. Sorry, then we have to use IA2. IA2 value will also substitute, that is minus EA minus IA1 Z1 divided by what's this? This is Z2, and IA1 will remain as it is. IA1 we don't have to change because we want to get everything in terms of IA1. I have substituted the value of IA0, which is this one, substitute the value of IA2, which is this one, and IA1 we have kept it like this. So now let me write it like this, or IA1 can be written as, I will write it, I will take what? I will take common EA, because this will go on the other side and it will become positive. EA minus IA1 Z1 I will take out of this. What will happen here? So This I will get 1 by Z2 second term, this term, plus this I am going to get 1 by Z0 plus 3Zn plus 3Zf. So this is the value I'm going to get from here. Now, what I'm writing now, I will just try to simplify this. IA1 will be, okay, IA1 will be, in this case, we'll try to simplify this, and we'll try to multiply this, sorry, what you call, just a second, this is gone, okay. Now we'll try to multiply this each and every term inside. So I will multiply it by EA first. This will be EA by Z2, okay. Then after that will be, I can write minus with this same term IA1, Z1 by Z2 minus IA1, Z1 divided by Z2. Again, I will multiply by EA plus EA divided by Z0 plus 3Zn plus 3Zf. So I'm writing this term complete. Again, I will multiply by IA1, IA1 Z1 divided by Z0 plus 3Zn plus 3Zf. Okay, so this is what we are getting till now. Okay, now you can see I'm trying to get IA1 common. That's the objective here. Okay. Okay, now here we'll try to get IA1 common. We'll take all the IA1 terms on the left hand side. So IA1 we'll try to get common. So here it is bracket. This one will be 1. This term here will be plus Z1 by Z2. This term here will be plus Z1 divided by Z0 plus 3Zn plus 3Zf. So this is the term we'll be getting on the left hand side. So right hand side, what will remain? E values will remain. EA I am going to get common out of this. 1 by Z2 plus 1 by Z0. Sorry, this is 3Zn here. Okay, this is 3Zn plus 3Zn plus 3Zf. Okay, this is what we are going to get on the right hand side. Now we'll be simplifying it further. Okay, IA1, I can write it like this. I will multiply this Z2 with this, and then because this will be the LCM complete, so I will multiply the complete LCM. Z2, Z0, 3Zn plus 3Zf. Okay, this is the first term. Then again, this term only we have to multiply by this term because this is in the denominator. So Z1 will be multiplied by Z0 plus 3Zn plus 3Zf. Okay, and then again this complete term will be multiplied. So Z1 will be multiplied by Z0 plus, okay, 3Zn plus 3Zf plus Z1, Z2. This is the last term which we'll be getting in the simplification. Divided by this whole term will be the same denominator what we'll be having. Z0, 3Zn plus 3Zf. Again, this will multiply both. This we are again Z1, what we are going to multiply. So we are going to multiply only this term. We are multiplying this. This Z1, what we are going to multiply only. Okay, we are going to multiply only Z1 plus Z2. Just a second, I have written it twice. Sorry, just a second. This should not come here. Why this is coming? Yeah, plus Z1, Z2. Okay. This term, both this denominator term will be multiplied. This term will be multiplied. This term will be multiplied. That's what we are getting. Bracket I will close here. So this is on the left hand side what we are getting. So let me write right hand side here will be equal to, so right hand side we have EA, okay, and this will be multiplying, the both terms will get multiplied there. So this one here, so that will be Z0 plus 3Zn plus 3Zf plus Z2 divided by, that term will be Z2, Z0, 3Zn plus 3Zf. So both simple cross multiplication is there, nothing else. Okay, so this is even. Now further simplifying it, IA1, now IA1 will take rest terms on the other side. IA1 will be EA multiplied by Z0 plus 3Zn plus 3Zf plus Z2. Okay, this is complete term here, and down we will have Z2, Z0 plus 3Zn plus 3Zf. Okay. Okay. So this term will go in the numerator. Yes, this should remain like this. Just a second. Yes. Okay. This will be in the numerator. This will be in the, yeah, why we are writing so much of terms? Just a second. Okay, see here, what we can do, this term will get cancelled, denominator term. Okay, so left term will be this numerator, fine, and this denominator term, that's what we need to write. We don't need to write anything. Plus Z1. These two terms will get cancelled. They are exactly the same. So denominator terms on both sides of the equation will get cancelled. Okay, so Z1 plus Z0 plus 3Zn plus 3Zf. So this is complete this one term, because that will come on the denominator on this side. Okay. Okay. So this much we have got. So IA1 we can write down. We can take this EA on the top. Okay. Now we'll divide everything by, dividing by, bracket we can write here, dividing by numerator and denominator by what? By Z0, 3Zn plus 3Zf. We'll divide it. So if we divide it, numerator will become EA. So here it will become Z2 plus, here we have Z2. Okay, this term we have divided, Z1 we have divided by, okay, what we have divided by, just a second. Yeah, Z1. This term we will divide. Okay, just a second. So we'll be dividing by Z1. Just a second. Yes. Just a second. I want to get it in terms of this. So we will be dividing by, yeah, Z2, Z0. So we'll be dividing by, why we are getting Z1 here? This would be Z2. Yeah, somewhere we have done mistake. Yeah, this should be Z2. See here, Z1 common is Z1. So inside there should be Z2. This is a mistake. So we'll be dividing by this term, dividing by Z2, Z0, 3Zn plus 3ZF. Now let's divide it. So dividing numerator and denominator. So Z0 3Zn, Z0 3Zn plus Z2 3ZF. We divide, this will become 1. So this will be here. Now exactly what is there with the Z1, we are dividing that. So it will be Z1 plus, so it will be Z2 multiplied by the same term 3ZF divided by this term, what we are dividing with, Z2 plus Z0, okay, Z2 plus Z0 plus 3Zn plus 3ZF. Okay, so let us call it equation number, or we can simplify it writing. This is simplified already, but we'll write it like this. Just a second. I1 can be further written as EA, okay, EA divided by EA, we can write it Z1 plus Z2 multiplied by Z0 plus 3Zn plus 3ZF, okay, divided by, we write it a bit like this, Z0 plus 3Zn for a zero sequence plus 3ZF fault impedance and with positive negative sequence Z2. So let us call it equation number 8. So on this basis, what we need to draw the interconnection of the sequence networks here. Here we can draw it. Everything is clear? Sana? हाँ बेटा.
Yes, sir.
Please understand the steps. ये difficult नहीं है. Simplification थोड़ा है. It's a mathematical simplification. ऐसा कोई difficult चीज नहीं है इसमें. So let me draw the interconnection of sequence networks, then we can conclude the class. So here we have interconnection of sequence network. Okay, now let's have a look here. So what we have IA1 current, that is, so we have like this. Simple, I am drawing. Sorry. It's a voltage source. This is the impedance. Okay. This is the impedance. Have a look here. Okay. This is impedance here. Diagram has to be drawn according to this relationship. Okay. Have a look here now. Sorry, here we have forgot. We can have a look. Here, let us say this is EA. Okay. Then this is Z1, this is Z2, this is Z0, 3Zn, 3 ZF, and this current we can say is your IA knots. See how we can find it. This current is, okay, what is this current? Sorry, this is IA1 here, and this is IA2. Okay, you can see IA1 is equal to what? EA voltage divided by Z1. In combination to Z1, these two are in parallel. These two combinations are in parallel, but what is this combination in series? Z0 plus 3Zn plus Z. So these combinations we'll put it in parallel. So when they will be in parallel, they will be Z2 into Z0 plus 3Zn plus ZF, 3ZF divided by Z2 plus Z0 plus so on and so forth. So this combination will be coming here. Once you are going to find this current IA1, so that will be EA1 in series with this. So this is the sequence network. I think this is clear, Sana? Beta?
Yes, sir.
It should be very clear. According to this equation, I have drawn this. So these are parallel combinations here. So parallel combination will come like this. And then once circuit reduces to this, so this will be in series. This will be in series with Z1. So this is in series with Z1. Current I1 will be voltage divided by total impedance. That will be like this. So that's all about the line-to-line fault. Double line to ground fault. So that was the last among the symmetrical. Then we'll have some numericals. After that, we'll have some numericals, some gate numericals, and that we should conclude this unit will be also concluded. Okay, let me stop this. Okay, so let me stop this.